Alright guys, one of the things that we need to cover and make sure that all of us are on the same page is the atom and the periodic table. These are kind of some of the baseline things that we need to know and understand in order for us to be successful in biotechnology. For those of you who are super familiar with this, please still watch the video so that you guys see our perspective on it. For everyone else, I hope that this is just kind of a good refresher and gives you a little bit of information. So usually we aren't too terribly worried about definitions of any kind, but we do want to at least kind of give you a baseline for what we mean when we say atom. So the atom is the smallest unit of matter that has the properties of any given element. So this can be said a number of different ways, but in essence, if you were to take something like aluminum foil and cut the aluminum foil in half. So let's just pretend here that we had a piece of aluminum foil and we cut this in half and then in half again, and then each of those pieces in half yet again, and just kept chopping this up into ever smaller pieces and smaller pieces and smaller pieces. How small can we kind of chop this piece of aluminum until it is no longer aluminum? Well, eventually you'll get to a single kind of point there in which that point is the smallest kind of representation of what aluminum still is. It will still behave like aluminum, and it still has all of those properties of aluminum, all the way down to just one single atom. So that's just kind of an analogy of sorts, kind of give you guys an idea of why the atom kind of came to be in the first place. Now, when we're talking about something called an element here, what we're talking about are things like carbon, which we represent with a capital C, or oxygen, which we represent with a capital O, something like silicon, we represent with S and I. So any one of these is, just examples of elements. If you've seen the periodic table, you've seen them all. So we're just going to briefly go over some of the components. Or kind of the pieces of an atom. If you think of anatomy as being the various pieces of a human, then this is kind of the anatomy, but of an atom. So let's talk about the nucleus here, kind of an important piece. And the nucleus is going to contain two of these major components, the protons and the neutrons. And usually the nucleus is kind of referred to as like this very dense single kind of point in the center of an atom, where all around this atom then we've got these kind of various rings and things. Okay, maybe that's not the best representation. Let's go with a kind of cleaner view. Something kind of along those lines. That might be a little bit more like our typical kind of view of the atom. So anyway, this little red kind of solid dense center is our nucleus. And out of the three different components, two of those components live there. So there's another component here that we're kind of showing and displaying in this outer rings here. These are where what we call the electrons live. And while this current representation as I have it now is more or less kind of the stereotypical atom, if you will, that we've seen before with these kind of concentric rings that go all around it, it's not exactly the best representation of the atom. So I'm actually going to kind of say like, nope, not really that one. There is a better representation, and I'm sure many of you guys have seen it. So let's go ahead and kind of draw that here. Solid centered nucleus. And then for our electrons, rather than being these kind of concentric rings that kind of make you look like it's a solar system, we'll kind of have these delineated dotted paths. And they kind of get larger and larger as we go out. I am definitely not the artist here, so for those of you who have more art skills than I do, feel free to laugh. There, something kind of like that. Now this is a more modern view, and this I think was kind of originally developed as we kind of got into a little bit more advanced kind of understanding of the atom. And I'm actually going to say, nope, that's also not the perfect representation. And in fact, anything that we draw is not going to be a perfect representation of what really is going on here. Perhaps one of the best ways we could represent this, if we had, this solid nucleus, that's about the only thing that we can draw really effectively. And then for all of our electrons and things, it's more like this kind of like path that just is unpredictable and all over and kind of layered on top of each other and just zigzagging and totally unpredictable. That's maybe the closest representation that we'll get if we're drawing this. So that's kind of our atom picture, denoting where all of those things are located. Now, one of the things that we'll do here is talk about each of these kinds of things and what their properties are. So let's talk about the proton, the neutron, and our electron. Now each of these has a charge. They are charged particles, and that really kind of defines what they are. For the proton, it has a positive charge. So I'll just kind of write really small beneath here that it's positive. And the reason I'm just writing it out is if you forget P in proton matches the P in positive. Okay? Now, the neutron we say is neutral. It has no charge. So neutral, I know that a number of people have written this another way before. They've written it with the positive / minus. Mr. Jordan and I are not real big fans of this method. So if you can, we'd like you guys to try to kind of avoid that. So we'd like to think of it as either having no charge or it being neutral. Now, similar to our proton and positive, if you look here, both of these start with the same letter. So neutron is neutral, pretty easy to remember. And then things get just a little bit weird here when we get to electron, where this is negative. And then I know that some people are like, oh, well, in negative, there's an E in the second there. If that's how you want to remember it, great. If you have other ways, then I think those are just fine. The other thing that I just want to kind of point out over here is the location of each of these. We've already kind of said this, but we can at least kind of put it in this almost kind of table view. The proton and the neutron both live in the nucleus. And those two together make the nucleus. So that dense kind of centered core thing, that is really your nucleus. And the electron is orbiting. So it orbits the nucleus. And even though this particular view, if I kind of go back here to our left-hand side, even though this particular view, in which I said, no, nope, not a good view, even though it's not the best view, these electrons that move around in this kind of chaotic, unpredictable pattern have ever so slightly predictable kind of paths following some kind of energy level. So that aspect where they are still kind of bound by these energy levels helps us predict a little bit of where they are. So actually this will have 2 points here. So it orbits the nucleus and there are various energy levels in which those are bound. Here's just a couple of other atom facts. So these are just kind of don't fit into that category, but are still good for you guys to know nonetheless. In a standard atom, so when we're talking about the atom, of carbon, of oxygen, of silicon, just the standard atom, the number of your protons is equal or offset by the number of electrons, which kind of has a second meaning here. The atom by itself usually is neutral overall. And what we mean by that is if you have an equal number of protons, and remember that our protons each carry a positive charge, and that is equal or exactly the same to the number of electrons, and those carry a negative charge, then your positives are counteracted by a negative. So that's why it ends up being neutral overall for your standard atom. We're not talking about ions. I know that some of you are already thinking that. The other thing is the number of protons is what determines the identity of the element. And I think there's a way that we can kind of better understand this second point, that the protons determine the identity of the element. And I've got us a little picture down here that'll help us. I'm going to use this as an example. Let's see if I can select this object and move it. Yes. Okay. So I'm just using zinc here as an example. There's no particular reason I picked it. I just picked it. So let's kind of, this is where the atom and the periodic table kind of join together and marry in this part of this video. What I want to look at is some of these different pieces here. So let's look at this first number. You guys can see that there's kind of a number of different pieces of information. Some of these are more obvious than others. This top value here, where for zinc it is 30, that's our atomic number. Here, these letters are the atomic like symbol or abbreviation, elemental symbol. There's a number of names for that. Zinc here is obviously the name. And then this bottom value here, 65.38, is called the atomic mass. So I'm just going to go over each of those pieces here. The 30 is the atomic number. And you get some information from this atomic number. So remember, the number of protons determines the identity of the element. So here's kind of your identity. This is your identifying number. So if it's the number of protons that tell us what this number is, then that tells us that that's the number of protons. But we also have this other information that I had mentioned up here. The number of protons for your standard atom equal the number of electrons. Okay, so then the atomic number can be your number of protons, and or the number of electrons as well. So for zinc specifically, since its atomic number is 30, I know that every atom of zinc will have both 30 protons and 30 electrons. Okay, here we've got next piece of information, this Zn here, the atomic or the atom abbreviation. And then, like I said, this could be also referred to as like the symbol, the atomic symbol, the elemental symbol, anything kind of along those lines. This zinc here is the atomic name. The quick little thing to point out, I guess, before we get too far ahead of ourselves. I want to point out one thing about the atom abbreviation or the atomic symbol here. You'll notice that it has two letters. Some have just one letter, and if I scroll up here, we can see that carbon has a single letter, oxygen has a single letter, silicon has two letters, like zinc. We always capitalize the first letter. And if you have a second letter, which not all of them do, the second letter is always lowercase. And that's to help us kind of understand where things start and where things end. This is a super quick kind of offshoot example here. If I write oxygen with the symbol, it's just this capital O. If I want to talk about carbon monoxide, these are both capitals, and so each of these capitals lets me know that each of those is its own atom. So this is an atom of carbon with an atom of oxygen because they're both capital. This is a different situation. A capital followed by a lowercase, this CO, is not the same as that other one. This one is one element together, so I'm not creating two little spaces there, and this represents cobalt. So it's kind of important that you guys keep track of that. Capital letter, and then if it has a second letter, it will always be lowercase. Just a good thing to kind of keep in mind. Last item here is our atomic mass. Now, the mass number, I'm going to kind of create a simple equation here. The mass of an atom is equal to your protons plus your neutrons. So that's kind of a total here. So from just the periodic table and the element here, you can get all of the information. The atomic number tells us that there are 30 protons and 30 electrons. And then the only piece of information that we're missing is our neutrons down here. But we can figure that out because we have the mass, 65.38, and we have the number of protons, 30. So we just can do some simple math and rearrange this here to figure out our number of neutrons. So our mass is 65, and I'm just going to round. I'm not going to worry about the decimals, and usually that's okay because these are whole numbers, and that's actually fine in this situation. So we have this mass of 65, we have 30 protons, so we would need to figure out, okay, well, how many neutrons would make this work? And if I do 65 minus 30 and just do some simple mental math there, I realize that zinc has 35 neutrons. And that's pretty much all we want to cover here for the very basics of the atom and the periodic table. if you kind of want to explore a periodic table and get kind of a feel for things, one of the ones that both Mr. Jordan and I use is called p-table. If you want to kind of check one out, it looks something like this. Let me see if I can quickly swap over to that. And here's where you guys can see that I got my zinc. I got that from p-table. This is just ptable.com, and it has a fully interactive kind of whole size periodic table for you guys to explore. So if you're interested, go ahead and take a look at it. It's one of the ones that Mr. Jordan and I appreciate and like, and it's got a lot of information, and they work hard to try and keep it up to date. Okay, I think that's all that we're going to talk about in terms of the atom and the periodic table. Hope this video was a good refresher for you guys, or I hope you guys learned something new.